All right, let's see if this is going to go. Oh, I got a slight headache. But we're going to do this anyway. Okay, so just go ahead and get things started. Okay. Where was I? I'm gonna grab this madoodle mababa doodle. Boop boop. Boop doop. All right, got one post posted. Probably make a couple more. One in the Beyond Code channel. Boom. Dun, 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 dun. Dun, dun, dun. All right. All righty. So I think I'm about ready to go then. We got chat up. Let me refresh here. Doesn't look like chat's up. All right, chat's up. Oh. Bum, 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 bum. I don't know about this track. Okay. I'll take another few seconds to get going. Bum, 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 bum. I've heard this one too many times. And this one. I think I've heard all of them too many times. I think I'm actually finally classical VGM'd out. Okay. Oh, we're up on time. Let's go ahead and switch over. Go! Okay. Hello, and welcome back. So, what we're working on today is TLS router, and it's going to be a good one because we get to work on the API. So, hopefully, well, I don't have enough time. I've got 2 hours. So, by the end of the session, what we will have is we'll have some API stuff. We'll have some be able to view connections, and maybe be able to update the config via API request. That's what I really need. I just need this thing to work so I can use it. I'm probably going to eat too many M&Ms unless I can put them away. I should probably put them away. I don't put them over here where I can't see them. I'll forget about them for a week. Okay. So where are we at now? Whoop. How's it going? All right, so where we left off was somewhere. But stuff is working. So I think I was able to, we got like the hello world route here. Let's see if it's still, if I refresh it, does it still work? Yeah, still works. Okay. Boom. So there's our uptime stuff. And oh, interesting. Little bug there. At 0 seconds, it reports the milliseconds. Huh. I might want to, I think I want to fix that real quick. That shouldn't be hard. So len parts. Huh, yeah, I don't, Oh. So what this actually becomes is like this. There's probably a simpler way to handle this. So this would just be if len parts is equal to 0. Maybe like this. Hold on, is it like this? If len parts is 0 or hours is greater than 0. Is that what we're doing? I think that's what we're doing. Hold on. Okay, I'm a little slow on the uptake right now, so forgive me. So I'm gonna walk this through because I had a bit of a headache and my brain is still a little foggy. So let me walk this through. I know it's simple. All right. So this is basically saying if there's been days or there are hours, then print the hours. If there's been days or hours, or there are minutes, print the minutes. If there's been days, hours, or minutes, or seconds, print the seconds. If there's not been none of that, then print the milliseconds. So we're guaranteed always to at least have milliseconds. Okay, that makes more sense. I gotta backport that into some other places. See what you get with AI slop, kids? Yeah, that's AI slop for you. Mostly right, but just wrong enough. All right, cool. Was that my only change so far? Yeah. I'm going to go ahead and commit that as a fix. Fix. Uptime. Cool. All right. So what was I actually going to do? I just saw that and so I decided to fix it. Okay, but look. That didn't do what we wanted it to do, what I wanted it to do, because I didn't actually restart the server. Okay, so let's restart the server. All right. It'll take a while. But if we give it 10 minutes or an hour, it'll eventually get there. Okay. All right, what is it that I wanted? All right, create, handle status, blah, 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 blah. I want to do connection tracking. That's what we want to implement. So I want to have an API endpoint where the endpoint serves up information about active connections. Whoop. Get status over here. Oh, and I had some things I was looking at on the other screen. And let me go find where I was doing the connection tracking. There's a couple things we got to do. We got to just, well, I want to actually be able to see what the data transfer is, encrypted and unencrypted, when we are dealing with unencrypted traffic. I want to see what's the overhead of the encryption. It should be nominal. Unless it's something like SSH where you're doing single keystrokes at a time. In that case, the packets are going to be particularly big. And in that case, having the AES salt, what's it called, is really, really important, because otherwise, if you could just decode what the encrypted keystrokes are. Oh, my whole nine is here. I'm gonna mute for a second. And I'm back. Okay, so where was I at? Oh yeah, looking at connection tracking. Let's see. Oh, I'm looking through some of the previous work that I did to see. Okay, basically, when we store a connection, when we know that we're accepting a connection, that we're going to handle it, those are the ones we're going to track. We are not going, for now, we're not going to track the ones that just error out immediately, just bogus connections that are not for a supported site. Actually, it would be interesting to see how many connections come in for what kinds of sites. So maybe we'll add that. So let's go ahead and add that. We're just gonna track. I don't know how we ought to do this because it could be gigabytes of information, but we will, whoops, it's not going to be here. Oh, and I see your message there. I'll check that out in just a second. Prom. Okay. So I'm just going to add just so we can see. Is it going to be the config struct? Maybe. Or do I want it to be the listen config? I actually think I want it to be in the listen config. What we'll do is we will have I'm going to call it TLS mismatches. And we'll just have a sync map. And when I create a new listen config, one of the things we'll do here is we'll have we'll put it under admin tunnel. I don't know why I'm putting anything anywhere. We'll do mismatches, and we will take the address of a sync map, and I will just use it to increment the counters in the sync map. Anyway, start letting go with the aim to work at infra-focused companies like HashiCorp. I have a front end, a little bit of full stack experience. I was wondering if you can help me understand what path in terms of projects I can follow so I'm able to apply for infra kind of job. I feel clueless right now. What project should I make? So I would go back around to, why do you want to do that? Why do you want to work at infra projects or infra focused companies? Because if you can figure out why you want to work at infra focused companies, there are probably some projects that you could work on that are aligned with the interest of why you want to do it in the first place. So that is my answer. But I think that this kind of a project is a good, like what I'm working on right now, I think this is a good kind of a project for something like that. Understanding the doing stuff where you understand the network stack, doing some stuff with proxies and TLS and Quick. Quick is something that not as many people know how to do stuff with right now. It's not in the standard library. But you got to figure out what it is that you want and you like. Why do you want to do it? Because if the answer is, well, I want to do it to make more money, that's a valid answer, but I'm not the right person to help you with that. Because I feel the joy when I write Docker files and everything works. It makes me wonder how people made such things. Okay. You're sick. You need healing. No, I hate Docker. I hate Docker so much. Because Docker to me is a symptom of a problem. And the problem is that people don't know what they're doing, and they don't bother to learn what they've done or to document what they've done. So Docker has become this, nobody understands what's going on, but thank goodness somebody put some stuff in a Docker file so that even though nobody knows how it's working and nobody can recreate it, at least there's a way to ship it. So I hate Docker. And if you use Go, then you don't need Docker, because the point of Docker is for things, particularly like Ruby and Python, where you have sprawling dependencies and there's just no hope of a reproducible build. That is the case where it's, Docker's the answer because you've chosen a really terrible set of tools that are just not going to work well. And it's not that Python is a great language to learn. It's a terrible language to use. Ruby, yeah, my problem with Ruby is just that for all of their, convention over configuration mentality in the Rails community, there's no standard distribution of Ruby. And that's what leads to all the rest of these problems, is that for whatever reason, the people behind Ruby have decided that they just don't want a standard distribution. And that sounds ridiculous in 2025, but, ruby.org. Maybe not. What? Rubylang.org? Tryruby.org? What? Come on. Ruby-lang.org. Right. Okay. So download Ruby. Yes, that's what I want to do. Ways of installing Ruby. We have several tools. There's no standard way to install Ruby. And all of these things suck, and they all half work. The only thing they provide are downloads, which this is just ridiculous. I don't know how they can call it a programmer's best friend when they don't even have a standard distribution. Node has a standard distribution, Go has standard distributions. Most programming languages in today's age, most of the modern ones have standard distributions. You can just download it, and it's not a huge matrix most of the time. But they don't have a single, not like, okay, well, we're only going to support Linux, Ubuntu, whatever. No, they're just like, screw it. We support nothing. Good luck, have fun. And yeah, so anyway, another example, when people write Terraform file and everything works. Well, you are picking the worst examples, man. Like, you are picking the things that are the symptoms. That's like saying when people cough and they don't die, It's like, wow, when people cough and they don't die, I just think it's magical. It makes me want to be a doctor. Like, when people write a Terraform form and everything works, it is a miracle. Oh, that stuff's too complicated for me. That's why I'm a Go developer. I don't have the brain space for that stuff, and I'm not amazed by it, because when I look at it, what I see is, pardon my français, mental masturbation. That's what I see. Now, that might be the wrong take. There might be that I'm just a stupid peon, and I work with companies that have like a max of 30 employees, and if only I were in charge of 100,000 servers, then I would see the light. But I'm kind of more the mindset of, I realize that there are some complexities that get introduced when you're going from, a rack with 7 servers to a data center with 1,000 servers. I'm not convinced that Terraform actually solves any of those problems. So anyway, yeah, well, JavaScript doesn't have to be so bad. Like, most of the JavaScript stuff works because you can write, unlike Python, you can write JavaScript in JavaScript. Like Python, you have to write in C because it's too slow. It's a toy language. It was meant for, you know, doing some admin stuff, whatever. People have taken it way too far, and I don't think that's to their credit. I think it's a great language to learn. It's just not a good language to use, you know, because learning how to program is one task. Programming is a different task. And I understand that we want this difference, but I think the weird thing is, okay, so you learned how to program using Python. All right, now go learn to program. But people then want to take Python and then program with it. And it's, I don't know. I don't know what the analogy would be, but it's like, it's a toy for children that's used by PhDs. So anyway, so yeah, let's talk about the project that I'm on instead of just offending everyone. So I'm working on a completely useless and senseless project, which is a TLS router. So it's useful for me because I do have servers in a data center, and this might sound silly, and it kind of is in a way, but the IPv4 is here to stay. For the next 100 years, we're going to be using IPv4. I don't believe that IPv6 over the next 100 years will become the predominant technology. Because the S-curve has already reached its end at around 50%. So if the S-curve had reached its end around, you know, like 85%, that's still way too low. But then we could say, okay, maybe it's going to get there. But where it reached its S-curve end and it started limiting at 50%, IPv6 is not going to happen. I think there's a lot of good use cases for IPv6, but your mom is never going to be using the internet on IPv6 because your mom actually wants to visit websites and doesn't want to have to deal with, oh, well, so-and-so didn't configure their website correctly and it's their fault. That's why she can't use websites on the internet. That just doesn't fly. Like, your mom doesn't care whose fault it is. She just wants to visit the websites. And if it's the ISP's fault, if it's, you know, somebody doing a deployment wrong, their fault, it doesn't matter whose fault it is. So, IPv4 is the future. It's the present and the future. And we don't, you know, the other thing that a lot of people don't realize is that IPv4, the problems that we have with it are mostly mitigated. And one of the things I'm surprised that we don't have really great tooling for, maybe just because it's internal to places like Google and AWS, but is TLS routing, because TLS gives you a server name and an application protocol. So SNI, server name indication, ALPN, application layer, ALPN, application, application layers, ALPN, protocol, application layer protocol. The N is for negotiation. So it's saying, here's the server I want to hit, and this is the protocol I want to hit it with. Well, that basically replaces IP and port. So you can use a server name in place of an IP address, and then resolve it, whether it's IPv6 or it's IPv4 or whatever it is, private addresses, no matter what, pretty much, on the back end, you know, between once you hit the thing and you're going inside the network. And then the ALPN basically replaces the port number. You don't have to worry about what port it's on. You just need to know what application am I trying to hit. And then all of that is obscured on the back end. So now we use port 443 for everything, no matter what it is. And the ALPN does the port negotiation and the server name does the IP negotiation, and that all happens behind the scenes. So I would say, obviously, this is being used heavily in infrastructure-heavy infrastructure, but it's not something where when I say, hey, what's the best TLS router? Where you're like, oh, I know, it's Caddy. Because Caddy is not the best TLS router. Haproxy does have some capabilities, but we need one that's just good and fluid and easy to use. And so I'm building one for myself, for my own company, for our own needs, with our own customers, to do that. Yeah, the mom problem. Why most industrial software is written in Java? I have no idea, because that's not the industry that I'm in. But I would imagine because, you know, it's really, if you don't get too much into the FizzBuzz factory, enterprise, factory, you can write workable software in Java and it can run in a lot of places. You know, it's got a lot of the advantages of Go. It's just based on academic mental self-aggrandizement rather than practical programming. So, you know, I think that Java has the same problems that C++ has, except it's a safe language. So, you know, you probably won't go to jail over it. I don't know if anybody goes to jail for C++. They probably should. But you just imagine how nice the world would be if it was like a doctor, you know, you professional malpractice. You kill someone, you don't really go to jail, but you know, you got to pay a lot of money in fines and, you know, maybe some bad stuff happens. Right? But imagine that, like, if people that shipped software that killed people, imagine if they had to go to jail or, you know, weren't allowed to work as software developers anymore. Nobody would use C++. People would still use Java, though. Anyway, so we got TLS mismatches. This is just a silly name for now, but it's what I'm going with. And so whenever we have something that we can't handle, I have a comment here for the unhappy path. Keep in mind we are 8 sessions into this project, so, you know, I'm not going to be able to explain every little thing here. But we have the unhappy path, which leads to the most unhappy path. Supported protos, blah, 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 blah. All right, so this one, client ALPN. So this one right here, this is where, so what I wanted to do is I want to say, you know, most of the time you're going to match on something directly. You know what I haven't accounted for yet, though? Wildcards. I got to account for wildcards. And wildcards, they probably can go in the happy path. But I haven't accounted for them yet. Anyway. So TLS mismatches, we have that here, and we're going to do, what is it? Load, store something. We're going to take whatever it was that the client wanted, which we're going to take what the client wanted as the server name. That's obvious. But then whatever the first supported protocol is. So supported protos, we're going to take the first one. So we're going to take key is server name plus supported protos. But the thing is, we have to make sure supported protos, ALPNs. There we go. So we're going to do domain and ALPNs 0 because we're guaranteed here that we at least put that one in. So let's do that. We're going to do domain and then ALPN 0 because the other one, if we were to index into 0, we don't know that there is a 0th. So we're going to store that. And then I just want to increment the number. I don't quite know what way I might do that. All right, let's do this. We're going to do get based on a key, and we're going to cast that to an atomic. I'm just going to go with int, because if it's more than 4 billion, or I guess I was going to do int32, because it's more than 4 billion, I just don't care. Oh, and then LC, there we go. or it's not get, it's load, right? And then we have to have some sort of, okay, so we gotta do V and okay. And then this, so I'm gonna call that V any. So if not okay, then I'm just gonna do a little this thingy. V any equals again, we'll do atomic dot int 32. I don't know if we need to do new on that. I don't think we do. And then we're gonna do a store of our v any here. I'll look at those comments in just a second. All right, so then we get our v, and we're gonna do v dot let's see. Let me go back to the atomics package here. Let me first look at sync and see if there's something else I could do for this. All right, load or store. Oh, wait. That actually works. Does it? All right, compare and swap. Previous any loaded bool. You know, I think a mutex is a better choice for this, actually. I think I might just do a mutex here, because I think I'm making it more complicated than I need to. But I'm also gonna look at the atomic real quick. You know, you learn a new tool and you just want to use it for everything. Okay, add int 32. No. This will work. This will work. No, this is good, because then I can just use the add. So then I'm using two. Well, it's still a mutex under the hood, blah, blah, blah. Okay, but I'm still adding to this, right? So add int 32. And then we've got these better ones here now. So add turns the old value. Yeah, so it updates the new value, returns the old value. So yeah, so what I'm going to do is I'm just going to do v add 1. Boom, that's all. And let's make sure that I'm using the atomics correctly. I'm pretty sure we don't have to call new on this, but let me just double check. Yeah, it doesn't look like we got to call new on this. But let me get all the way up here. Yeah, the new value versus the old value, but we don't call new on it to initialize. It is what it is. All right. Interesting project. I think this would be good starting point. Anyway, can I follow this project? Of course you can. Always being there in stream is impossible for me. Yeah, so I don't know if I've made it public yet, because I try not to release things publicly until they're actually useful. And this is not useful yet, but because I've been streaming it, I think I did make it public. So it says it's a public repository. So here you go. Boom. Yeah. I guess Java is good enough language that can scale. Go is better. You are welcome. Java is good enough language that can scale. Yeah, I think the good thing about Go, the really, really great thing about Go, is that when people use Go, they already have agreed to a certain set of values. Okay, it's like being Jewish. All right, if two Jewish people are doing business together, like this is why everybody hates the Jews, right? Because they're shrewd and they're, you know, like they're very, very efficient and they make a lot of money, right? So, or that's the stereotype. But anyway, but if you're two Jewish people and you have the same set of values and you're meticulous and you're about like the letter of the law and, you know, exact sets of circumstances, and you know how you communicate, right? You know what you've agreed to. You know the subset of operations that you allow. Then you have a lot less overhead to be able to do business together. And there's just a bunch of community enforcement stuff. So I'm not trying to, you know, put Jews in a box and say all Jews are like this or like that or whatever. I'm just using an example because it's, you know, it's a common stereotype. And I think it's well understood that there's a certain efficiency that comes from having a shared set of beliefs and values. And I mean, that's pretty obvious, right? So when you adopt Go, you are adopting a shared set of beliefs and values. If you don't believe in the values in Go, you just won't use Go because you have a lot of other options out there. So in Go, it's hard, like Go gives you a pit of success for simplicity. You have more boilerplate, but the code is simpler. And when you look at other languages, a lot of them don't have that pit of success. So take for example Swift. Swift is far more complex than Go. There's a lot of cool things in Swift that I like. As I learn more about it, yeah, I really do like it. But there's 10 different ways to do everything, and so then you have to have code standards because you don't want to have inconsistency where, you know, you just want to have smaller surface areas, right? And so most languages, you could write code as clean as Go. In JavaScript, you can write very Go-like code. Go and JavaScript are actually very, very similar. If you look at it from the perspective of Go, writing JavaScript, you can write really similar JavaScript. But if you look at it from the perspective of TypeScript, TypeScript is insanely complicated, which is why I think that it's so ironic that they chose Go as the language to implement the TypeScript compiler in for the new compiler. Because, well, and they themselves say that basically in their TypeScript, they basically don't use TypeScript because it's so complicated that they can't use it. And so using a language like Go that's really simple, even though TypeScript is an incredibly complicated language, it's easier for them to write the TypeScript compiler in Go than it is to write it in TypeScript. So, I mean, like, there's something meta there that you got to come to the recognition of. We don't need programs that allow us to programming languages that allow us to express our artistic creativity. We need programming languages that allow us to write programs that work. Douglas Crockford had this right. I mean, he was the one that was in charge of JavaScript when I got into web development. So I came into that era, and you know, things have gone off the rails since, but it is possible in any programming language, it's possible to find the subset of the language that you can use and write comprehensible, correct programs. Some languages encourage the opposite. They encourage people to have diverse viewpoints that are unaligned and just waste time. So, yeah. Maybe since they wrote the compiler in Go because of performance requirements? Well, yes, of course. But it's like Go is not the most performant, you know? They could have written it in Java and gotten similar performance. They certainly could have written it in Rust or Zig and gotten better performance. Now, Zig is still changing all the time, so that would be horrible for a project that massive. But, you know, Go is not... the value of Go is not its speed. It just happens to be, because I mean, even the reason that Go compiles so fast is that there is no optimized mode for Go. There is no Go build -03, right? They just make a lot of trade-offs for simplicity, and it turns out that the simple way to do things is often far better than what people are already dealing with. And so it seems like Go is this amazingly fast language, but it's not. They just don't do as much stupid. Because when you have to deal with so much simple, you don't have as room for as much stupid. You get what I'm saying? All right, so we're gonna load this key. If we don't have anything, then we're gonna stick something in there, and then we're gonna add one to it. Oh no. Uh-oh. That's not good. What did I just lose? Do we still have sound? Can you still hear me on the mic? Because loopback crashing, that's one of the audio subsystems. So, okay, good. All right, did we lose the... Okay, it looks like you heard that. It looks like you can hear me. It looks like you can still hear VLC. What is loopback doing then? Am I not using loopback anymore? Is it just running in the background? Maybe I am not actually using loopback. Oh, because I'm running my mic now through a macOS MIDI device because of reasons. So we're not using it for that. The system catch-all is being used for the speakers, but maybe it was the application that crashed and not the device driver. Huh. Anyway, that's kind of weird. All right, cool. Audio's good. Hey, what's up, Joseph? And nobody. I didn't recognize nobody. Yeah, Zig is cool, but not mature. Yeah, I'm really interested to see what happens with Zig because it just seems like the perfect language in terms of it's got all the simplicity of Go, kind of. Zig, it seems like Zig is the first low-level programming language, which is, it's really interesting. But there's never been, unless you count some Franken combination of linker script and like I don't know of any low-level programming language. When you see the way that Zig, okay, so like for example, what's low level? Using atomics. Atomics is low level. Go is not a low level programming language, but it does give me access to some low level operations, right? So, languages, high level languages like C don't expose this at all. Like high level dynamic languages like C, where like the no type safety, you have to write an assembly if you want to get any instructions, particular instructions. Like they don't have the facility for it. In Go, you used to have to write assembly to do this type of stuff, but now they expose it as part of the language. Now the way that they expose it in the language is a little bit, it doesn't have the syntactical nicety that you get with like a plus operator, but I don't know what else we would do. And so, they just call it add, but it's an assembly instruction. And if the compiler target supports it, then it writes out the assembly. Otherwise, it creates a high level abstraction for it, which is like a mutex and addition or something like that. Right. So anyway, that's the thing that I think is the most interesting about Zig is no one has ever bothered to invent a low-level programming language until Zig came along. So that's interesting. And I do like seeing low-level features added in Go and ostensibly other languages, although I haven't noticed, because I didn't realize the utility of low-level programming features because I'd never had them available to me. Like all I knew was if you want to add stuff together, plus I didn't know about compare and swap or atomic add. Like I didn't know the benefit of that. But now that I do, it's like, yeah, I want to use it. And I kind of wish that atomic add was the default, but I don't know what penalty that would have. Or if the compiler well, I guess that's kind of sometimes maybe what it tries to do. tries to infer if an atomic ad is what's necessary. I don't know. Anyway, so here we are. So we've got our TLS mismatches, and we're going to store those. And then we also need to store the moment at which we know that we're going to handle the thing. And let me go back and look. I think I just found one point at which I could do that, but I'm going to look and see. No, there's a couple points. What's up, buddy? Okay, that's all right, son. I don't need it right now. All right, I'm gonna take the package. All right, where is it, son? All right, go ahead, bring it here.
Maybe.
Nope, nope.
Or maybe.
Do you want me to open it and see what it is? Let's open it and see what it is. I don't know what it is, actually. Oh, it's just screws. Oh, these are too short. Oh, they're not going to work. Oh, no. Really? They're 16ths. That's not going to work at all. Oh, well. Oopsie daisies. All right. Thanks, buddy. I know. I should be excited. My son knocked on the door, right? But sometimes, well, I don't know. This is very hypocritical because here I am just chatting it up with people online. But, you know, I just want to focus on work, and sometimes the fact that I work out of a shed at my house makes it a little difficult with the interruptions, and the kids have already interrupted several times before I actually got on stream while I was doing some other stuff. And yeah. But I do, yeah, never mind. I'd like to think I'm not a terrible human. Maybe I am. But normally, most of the time, I'm happy when the kids come to the door, but they've just interrupted a bunch already this morning. Okay. Anyway. All right. They'd written a good blog on why the shows go over Rust. You can read the official blog and your questions would be answered. Yeah. Yeah, I haven't read the blog post. I watched the podcast. But anyway, I ordered some screws and they are not what I need. They are definitely not what I need. They are way too countersunk. Let me show. Well, I don't know if I can. Will it focus? Yeah, it will. Okay, and then you probably can't see any of that. Anyway, they are just way too countersunk. I was expecting like a little countersink, but they are way countersunk. And so I don't think I'm going to be able to use them. And I don't know if I can return them or if it would even be worth it to return them. I thought I got exactly the size that I needed because I was expecting the head to be 1.5 millimeters, but the head is over half the size of the entire screw. And I was expecting just a little bit, but they're not right. So there's not enough thread there to be able to screw in hard drives. Okay, so I'm going to make a note of that. That's because I was making a note somewhere else of where, you know, it's weird that it's so hard to find a standard name. You know, you want a particular type of screw, and it's like, I don't want a random screw, and I don't want to pay 10 times more to get a Dell branded screw. I just want to know what is the type of screw that we're dealing with and then get that screw. And this, I was obviously wrong. So, yes. Do not get countersunk. Yeah, these are not the size that I thought they were. I would like to measure them. But I was expecting about 1 millimeter to 1.5 millimeters on the countersink. Anyway. Yeah, it's not going to work. I will have to order again. Dang it. Okay, so let's deal with this, because I actually do want to get somewhere on here. Okay, so I had a few different places where I was storing the connections. I don't know if I need to retrieve them. It might be fine just to use... If I use... Problem is, if I use a slice, then unless it's as big as it could possibly ever be, then I'm just better off using a map. I kind of just need a set, but I don't know what key should the set be by. All right. Let's see. Do I have in here? I don't think I have in here where I'm tracking the connection. Okay, there is a thing there I need to do. List connections. Yes, that's good. Okay, that's all in here. Okay, so what is it that I need to do then? All right, there's one place. There's two place. There's two places I think where I need to store the accepted connection. So I'm going to go... Basically, it's right around where there's a pass-through, I think. So once we know that there's a back end, where did the back end go? So back end... So these count as accepted connections as well. So technically, there should be other ones. Well, yeah, I guess I want to store this one too. So what I want to be able to do with the connections is I want to be able to terminate them. Ultimately, I want to be able to track and terminate them. All right, return TLS config. So maybe what I want to do is right after all this TLS stuff, once I've got the TLS con, is that where I want to handle it? New TLS. I gotta see here. So plain con. So there's this one, right to blah, 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 proxy protocol, blah, 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 blah. Now I can't remember. Header, right to. Oh, error. If there's an error, that's when I return. If there's an error. Otherwise, I don't need to worry about that. So basically, I think it just should be right here always, no matter what. Or am I wrong in that? Because where am I doing the plane connection? So this is the plane connection. I'm taking the TLS connection. But what if I'm not taking the TLS connection? What if we're just proxying? So let's see here. All right. Okay, here we go. So right here is where, all right, we're not terminating the TLS and we might be doing the proxy protocol, and we're going to copy the connection. So this is where we should be doing store accepted connection. And we also want to have the information about which protocol was accepted for this. So this is where SNI ALPN, we set it up here when the connection is managed, and then we're trying to see, does that exist? Does that exist? Does that exist? Okay. So it's got to exist in one of these places. And then there's also here, we need to set this here as well. So client ALPN, blah, 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 blah. Okay, so this one's bad and this one's good. So here we can set ALPN, and this is going to be correct, and we'll do it the same. But wherever we break, essentially, we're going to make that an empty string. Wait. How did I do this? We're trying an ALPN. We're trying an ALPN. So these are not confirmed. These are tried. And then, okay. Client ALPN. Oh, okay. So what I wanted to do here, so I got these two things. All right, this is what I'm going to do. We're going to do track mismatch. I'm going to throw all that into here. And then I'm going to do the same thing in both of these places. All right, there we go. So that will work. This is really ugly. I'm not super excited about this. But, you know, show me a better way. All right, so kids have to understand boundaries. Daddy is working, and this is Daddy's office. Don't feel bad. Yeah. It depends on the day and the time. Like, it is a Saturday. But I am doing something that right now I'm actually held up. I've actually hit the point where there are two clients that I cannot service because I do not have this solution. So today I will be working on this. I've got a call in about an hour with another potential client, because, you know, when you work with small people, we do business on Saturdays. But yeah, things are, you know, because I don't work a 9 to 5. That comes with pros and cons. The pro it comes with is that I don't get fired every 6 months. The con that it comes with is that I don't have good family work boundaries. And And the reason I say the pro is that I don't get fired every 6 months is that I just can't work a 9 to 5. I am too, my brain is too weird. Like I can do amazing magical things, but I can't do them. I do them at 3 a.m. You know, like I'm the nutty professor. So yeah, I freelance. So I work for how many? There's two main clients I have right now, and there's a third that I'm picking up. I did have one previously, but uh I it was I was becoming a worse person. I was just angry all the time. I was frustrated. I wasn't behaving well. I really kind of wanted to get fired, but then they kept on not firing me and just asking me to do more anyway. So then I just had worse behavior and then was becoming a worse person. And then I don't remember what the cutoff was, but at some point, I guess like my risk threshold was reached because it was just the things like when I would get paid or if I would get paid or how much money was available for a project started to become really outside of my threshold for tolerance. And then me having to be more involved with more people. Like I really don't want to be involved with more people. I don't want to BS and play games and like I'm not good at that stuff. That's not me, and that's not an area where I really want to grow. I want to just be better at I want to sell more technical products. I want to have some revenue streams that are ongoing, which is this is lending towards that. So one of the clients that I'm picking up is going to be in like basically a monthly amount where I'm occasionally going to handle it's going to be hopefully kind of more like a retainer where they get a base level of services and I occasionally have to do manual work for them, but I'm just maintaining some stuff for them at a lower cost than their current service costs. And ostensibly with better service. Now that's not firm yet. We're in a testing phase, but so far things are looking good that I'm going to be able to give them what they want with better outcomes than what they're getting presently, which is why they were looking for other opportunities for their needs. Anyway, yeah. I tried freelancing. I didn't get serious clients. It's not easy, to be honest, respect you. But I've always done it. I've done it since I was 14 years old. So it's basically all I know, and I've never had to look for work. I'm just a loudmouth and I tell people about what I'm doing, and now I stream what I'm doing, and I would present at conferences about what I was doing, and things were different 10 years ago. If you maintained a blog, like I used to be pretty active maintaining a blog of stuff that I was learning, and I would get clients from it because they would, back then, search worked. Like right now, search is a joke. Like you put in keywords on a search engine and you hit enter, and the results that come back may have 0 of your keywords. It might instead have similar words like you put in trot and it gives you back results for walk, that sort of thing. Like now it does synonym comparison. So keywords don't mean anything anymore. Search is a joke now because it got so big that all they can do is statistical analysis. They can't actually traverse the data anymore, which is why I think seems to be why LLMs came about in the first place, is they were trying to optimize the search stuff, and then my understanding is that they stumbled upon some novel properties of the statistical analysis mumbo jumbo, and Google was doing it before anybody said ChatGPT. Google was already, you could see the search results were being replaced with LLM stuff. Anyway, yeah, so it was a different game back then. Now the game's changing, and because of that, I actually don't know how to adapt to it. And so I've actually started picking up more IT work because I don't know how to adapt to the programming landscape, but the IT landscape is easier for me to understand. So I'm picking up more infra slash IT stuff, but not infra like web devs talk about infra like servers. You know, things that you actually become proficient in. Again, no offense to you and your Terraform files. Gonna have a seizure, a Terraform seizure. No, I don't even know enough about that stuff to criticize it. Really. To me, it's too complicated. Like, to me, setting up a service in Linux is something that takes all of 0 minutes. Like, I literally have a script that I've written that is how I set up services in Linux. It is called Serviceman. This is how I set up services in Linux. I go into the directory where I have the service. I run the service with the arguments. So here's an example right here. You know, if I wanted to write a service that was a bash script, boom, that's how I do it. If I want to do one that's a node script, boom, boom, Golang, boom. Except that this is outdated. You don't need to put mod equals vendor anymore. But yeah, I mean, that, like, it doesn't take me time to do that. So yeah, so I'm very comfortable with the Linux stuff. I don't find it to be overwhelming. Like, for me, you know, having to edit a log rotate file, it's like, oh crap, I forgot to do that. But it's not overwhelming, like, oh, I'm never gonna be able to figure this out. When I look at a Terraform file, I don't know what I would be saving. Because to me, it's like, okay, I can write a script that just SSHs into 5 different servers and run some stuff. And maybe I don't absolutely love what I end up with because of the complexities in it, but I'm not sitting there debugging a YAML file, right? I'm not sitting there writing a JSON alternative to write bash. I just write the bash. Well, I write POSIX script, but, you know, similar. Anyway. All right, so we track the mismatches. Now let's actually get to the thing. ALPN. I was going to put the ALPN modoodle somewhere. So I got the ALPNs, and then there was somewhere here. All right, we're going to find a backend. All right, debug, terminate the TLS. So we are terminating the TLS. No terminate TLS. Okay, so that doesn't matter. Either way, we're going to get here. So either way, we're going to get to, yeah, extort accepted connection, and then we have SNI ALPN. Because that, I'm just going to use that information. I'm just going to attach that information to the connection. I'm gonna create a little connection wrapper. Okay, so in this case, do not terminate. So this is the where we're just gonna go straight through with this. I mean, I guess it would be just as well to put this here. Well, I guess if we could have an error, and so I don't want to do it if there's an error, I guess. Okay. And then this is all error conditions. So we're not going to track on error conditions. This is a success condition. These are error conditions. This one, even though it's an error, the error is do not terminate. So it's still a success condition. And then other than that, we are going to do it here. I mean, I guess what we could do is we could just say, all right, if we got to this point, we're going to store it. And then if there's an error, we're just going to delete it right away or mark it as inactive or something like that. That could be a way to do it. In fact, sure, why not? But no, wait, because we have different things we need to store. So this one and this one, we need to store the HC. That is the hello client or the hello connection. That's what we need to store. And then in this one, are we storing the same thing? We're storing something different. So in this one, How do we have it? I think we need to create a different connection type. So we got the TLS Conn. Was it right here? No, it's right. So TLS Conn. Are we storing the TLS Conn? What are we storing? I think I need to add the TLS connection to this connection. Okay. All right. Terraform, Kubernetes, etc. All the madness of modern web development terrible. Yes, that's where I'm at. That is where I'm at. Terraform isn't for one Linux machine, anyways. It can be 10 Linux machines, right? Like, I don't have a problem looping over a list of machines. I just don't think people, okay, somebody maybe has the problem that it solves, but most people, I think it's a form of self-aggrandizement. They want to imagine that like, it empowers them, makes them feel good, makes them feel like they have the problem that it solves, when really they could just be running 3 VPSs at $15 a month and they'd get all their stuff. Okay, gotta go. Have a chill, productive stream. See you sometime in the future. Thank you. You too. So that's my take. Is I don't think that people are actually having those problems. I think that they want it's aspirational. Okay, let's put it that way. I think that Terraform and Docker are aspirational technologies. They make people feel like one day I'm going to have so many problems that all of this is going to be worth it. But I'm more in the camp of DHH, where he is doing some complicated stuff, and he does have to use Docker because he uses Ruby. And I think that I think it's reasonable to say that you can't have a Ruby deployment without Docker, or that you could. I mean, this is what I would rather do. Is I would rather say, look, we're only supporting Ubuntu blah blah blah. Run an instance with Ubuntu blah blah blah. I would rather do that. But I think that there is a use case for Docker. I love containers. I don't like the complexity of Docker, and I don't like how Docker replaces documentation. But but it doesn't replace it. It's a poor substitute is what I mean to say. Anyway. But yeah, like with what he's doing, because he's chosen Ruby, I don't know. I don't know why you choose Ruby when you can choose Go, other than that, obviously, he being one of the Rails guys, he's kind of the Rails guy. He's gonna stick with that. Anyway, all right. Where was I at? Okay. Okay, there's some stuff here I think I got in the wrong order. I'm looking at where I had this before, because I actually did some of this. Well, I did almost all of the work before, but then I felt like the stream was too meandering, and so I just decided to do it again. And it turns out it's not easier to do the second time. I thought, oh, I'll be done with this in 15 minutes. First stream was 5.5 hours. We're pretty much up on that time frame for the amount of time I've spent redoing it. And it's not necessarily better. It's just, oh, so I lesson learned there, maybe. Okay. I don't remember where I need to put this. I think it is right here. I think this is where I need to put it. I think I need to put it right above. Yeah. And I need, so we're going to create something to store this, but then we also need to do this. So we've got that TLS. I think we still need the hello Conn, but we also need to track the TLS Conn. No, is this right? This is not right. This doesn't quite make sense. Because when I do new TLS con and I get the C con, what am I actually getting out of there? Do I want TLS con to be TLS con? All right, I'm just going to copy some stuff over. I had a type that I created. The type is called TLS con. And I'm not actually sure, now that I'm looking at this, I mean, I guess I'm glad I'm looking at this again. I'm not actually sure it's the right thing. Where did this come from? Do I already have a TLS con? Do I already have that as a type in here? Yes, I do. So it has the underlying TLS connection. Got it. That's why this one works. This is the wrapped one that has the bytes read and bytes written. Got it. Okay, so what we're going to do then is we're going to go back to this. Yes, okay. We're going to go to our hello con. TLS, hello. And I got to rename this stuff at some point. But we're going to have a TLS con, which is of type TLS con. And this may be nil. Yeah, so TLS con star, well, no, just TLS con. And I think am I going to leave that like that? Yeah, okay. All right, type is not an expression. So this is just going to be nil. That's what we're going to do. And then if we actually decrypt it, that's where we assign it there. All right, so we need to take this store accepted connection, and I kind of want to put it near here, I guess. Where did I put it last time? And this one is going to be, we are going to use the actual type of TLS hello con. And so this will be con, I think. And then we're going to use SNI ALPN. And then I don't think we're going to have anything else. We're just going to do it like that. Let me double check on this. Yeah, in retrospect, I think that this was actually a poor choice to redo this work. I really thought I was going to, because once I figured everything out, I was like, oh, this is simple, but it's still a lot of mental overhead the second time around. It would be really interesting to try to plan this out to make this a tutorial video of how to write a TLS router. Because yeah, well, first I'd have to refactor this and get all the names right. I think it would be cool if I could do it in like a 3-hour session, get the whole thing together. I think I'd actually like to do that, but I don't know if just for my own personal enjoyment, because I don't know how much benefit it would really be to the world. But anyway, all right. So we're gonna say now. So what we need to do is we need to store a timestamp about when this was connected. So maybe I'll just call that HC. Yeah. And then what am I gonna do with that now? Oh, it's going to be, okay, so here's the thing. This is one of the things I was trying to figure out. So if we go back to the config file here. All right, so I wanted to have the connections. I just don't know where I actually want to put this stuff. Maybe I should just do it alphabetically because I don't know of a better way, and this looks really ugly right now. I think I had it right after admin tunnel. Yeah, so that kind of makes sense. And I was going to do this. Okay, this is going to be a sync map. This is, yeah, this is going to be a sync map as well. So this one was going to be Conn's, right? And so here, do and sync map. I think I did makes or new sync map in the other one. Or maybe, wait, because this one, hold on, here's the thing. This doesn't actually need, because the listen config is already a pointer, so none of these things inside have to be pointers. It's fine to pass around the sync map that way. Yeah, okay, so we don't actually have to have those be pointers. So let me go back, sync.map. We can get rid of the pointers here. We could probably get rid of the pointer here too. Yeah, because that's a container type, but it contains a mutex, which is why it needs a pointer. Because you don't want to copy the mutex. You want to have the actual mutex use it. Anyway, so I needed to add some more state to this as well for the connection of information about the server name and the chosen protocol. That was something I was going to add. So let me go back and take a look at this. Or maybe, let's see, was I going to do it with, I think I had a wrapper connection that I was going to use. New TLS, no, was it TLS hello Conn? And then what was I going to do here? Is that right? Okay, I'm just going to copy this over because this is what I actually used in the previous implementation. All right, so let me go over what I'm doing here. So I need some element of randomness. That's why I'm using time.now. So I want Unix milliseconds. The idea being that I couldn't have something from the same IP and port in the same millisecond, which is not entirely true, but it's true from the perspective that a TCP session is defined by the pairing of the IP and port, because that's how it knows what to go back to. So from a practical perspective, if we had to overwrite this, that it would be fine. All right, so IP and port, TCP or UDP, address. So that this is not really an address, this is a key. So let's rename that to key, because that's what this is. So we're going to store this connection in here by this information. And this is just a holdover because I'm not sure exactly what I want to do, because it should be that these are unique enough, but I want a way that, let's say that you disconnect and you reconnect and you use the same port when you reconnect, the same source port when you reconnect. I kind of want to track that connection, so I just want this random component. But at that point, everything might as well be random. You know, it's 6 of one, half a dozen of the other. But I think that that's not even what I ended up doing, because I ended up, let's see, did I get this right? No, that's what I had for the API. Okay. And I need to split this out into different files. There's a lot of refactoring that needs to be done here because it's just not, it's not what it needs to be. But let me just start a different file. Wait, why was this griping about something? Oh, whatever. So let's call this API.go. So we're going to have some more information that's API information. So I'm going to have I don't know why I'm calling it a PCon. It might as well be called a TCon, a tunnel connection. I don't remember why I called it PCon. Probably because PCon sounds cool. That's probably why I did it. That's probably the real reason, because PCon sounds cool. And then we're going to have Okay, yes. Yes, 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 yes. So I wanted to make this JSON friendly. And we often have this problem in JSON where int64s are represented as either, I don't know what they get represented as strings, I guess. I don't remember what it is by default, because technically JSON can't handle an N64, but most of the time you don't actually need, unless you're doing a random number, you don't need int64. If you're doing time or a counter or any of that, an int52 is just fine. So what I do is I create a type that's an int52, and then I just have it marshal and unmarshal as a number as far as JSON's concerned. And I could do it as a float 64, and but it's an int, and I just want it to be an int, and the int52 is usually fine. So where I believe that an int52 is fine, because I don't think an int32 is fine, because you easily write you easily have more than 4 gigabytes of traffic, but you don't easily have more than whatever this number is of traffic. I mean, I think you get around to an int 48 and you're just not going to have that much traffic. But let's see. I'm tracking bandwidth. How many petabytes can I record with a 52-bit integer? Okay, yeah. So the question is, am I worried about 4.5 petabytes, the number being greater than 4.5 petabytes? And my answer is, no, I'm not. I'm not worried about it being greater than 4.5 petabytes. Ugh. Of course, I could represent it as a string as well. So how about a 64-bit integer? So I think exabytes is larger than zettabytes, maybe. Oh, really? Are they only that much different? That doesn't make sense. Intuitively, I feel like this is wrong. I don't think that they would be that close, where this could only track petabytes, but that could track exabytes when we've got an extra 12. So if we multiply this by itself 12 times, does that, whatever. Anyway, moving on. Point is, whatever the point was. All right, so we're going to do a little list connections here. I'm actually going to put this in this file here for the time being. And I kind of want to lift this up to here. Blah, blah, blah. There we go. I don't know how that all gets copied in when I'm copying over from GitHub. Okay, anyway. So, I had to add this new thing here, which I didn't add yet. So let me go back and add that. So TLS hello Conn is going to need to have Actually, we're just not going to have that yet. So when we store accepted, we didn't even do anything with ALPN here. Okay. That's when we need to add the ALPN. I guess we could technically do it before. Is that what I did in the other one? Yeah. So it seems like I probably could have done this earlier on, and maybe I will. Maybe we won't put this here, but we'll go back to where store accepted. Conn, let's go get rid of this. Go get rid of this. And let's instead look where ALPN is actually saved. Well, I guess it's about the same place, so actually it makes sense. I don't know. Logically, I feel like they're separate. They're not related. But before I store it, well, I guess we could do it right here, right? Yeah. There we go. So here, after that connection, is where we're going to handle it. Okay, I like that idea. I also like the idea of putting it where we actually use it. But there are cases where we handle it, like right here, but we're not ready to use it yet. But I guess, I don't know. I mean, I guess. Because we could say for that, I don't know. I like the place where I put it. Which really makes me think we should do the same thing with this. We just put them both here. Because now the only case where they're not going to be handled there. That basically lets us know that it was handled. Well, it doesn't really. Oh, especially because this was only a setup, right? TLS Conn, yeah. So that is not correct. So, okay, that was wrong. All right, so we're gonna go back. We're gonna go back. We're gonna go back. Yeah. All right, it's got to be there. Because it's not until this handshake. Let's see. If the error is do not terminate. I almost want to do it like this. And then not have to worry about it, but no. I'll figure it out later when I'm in a refactoring phase, but yeah, this is just messy code. Stateful code like this is just messy. It's just messy. It's very it's very hard to deal with in a sane way because there's just a bunch of different conditions that could happen. One thing that would make this a lot cleaner is if I had a true peaker mechanism and I could do the peaking, and maybe I can abstract this out into a peak function. So take both of these, this function and this function, and just abstract it out into a peak function where I get my connection and I get the HC back like right here, and all of this just goes in there, and all the nastiness that has to be dealt with here just goes in there. And then when the thing comes back, let's see, because once we get to this point, again, if there's an error, whatever. Yeah, I think I just want to deal with the errors, the unhappy path differently to make this cleaner. And just say we're going to do more work if there's an error. So what I could do is I could defer and let's see, store accepted Conn. Actually, I probably should just do this anyway. Let me think about this again. Yeah, okay, this is what I think I would like to do. I think I would like to take that whole big huge chunk, move it all into its own function, and get back the hello Conn, whether or not it's a TLS connection or whether or not it's being terminated, and an error. So let's see what that would look like. Well, first let's get a little bit further along and actually save before I go refactoring. Red, green, refactor, you know? Let's actually get something working before I refactor and just screw it all up. But yeah, I think that would make me feel a lot better is if I had a nice abstraction around this where I could take all this ugliness that has so much state wiffle waffle and then just have a single, you know, if there was an error, go ahead and return the bytes, have a defer in here, and I think I'll go ahead and do the defer. So let's just go ahead and do that defer. So defer, func. And what we're going to do here is lc.cons. Let's see. We're going to happy path is, all right, we're going to create the Conn ID. We can't create the Conn ID yet, can we? Or can we? Then we can make this a lot simpler. if we can do var Conn ID string, loop that all up. All right, so just bring this up right away. Okay, boom. Yeah, we're gonna worry about the other problem with this later. That makes this a lot simpler. I like this much more. And maybe we just get rid of Conn ID from there and just no, because we have to have. All right, so time is connected at, so time.now. Don't we have another one of these, new hello Conn connected? So we already got that. So we don't even need that one. Okay, so let's take that away. So then I don't know why I wasn't using this before, but we can just get rid of the now because it's just hc.connected.unixmili. And so then, yeah, then we just repeat the same thing here. We just do that task, and we don't store that at all. Yeah, this is starting to take better shape. I think we just need to separate the what we're doing with proxying from what we're doing with matching so that it feels a little less discombobulated. And this whole thing just returns the pieces that it needs to, the back end. All right, anyway, let's move on. How y'all doing, by the way? Feel free to comment, ask questions, whatever. Okay, so that's stored. And this is a pointer, so this updates the thing that is in the map. Which means we do have a problem doing it this way, which is that we are creating a race condition when we do it like that. So it would be better, which again, all of this becomes a lot easier to handle if we just abstract this away into its own function. So maybe I do want to do that now. I really don't want to do that right now, but maybe I do. Because now we have a race condition that we didn't have before. Let me just go ahead and move this. Okay, so right here, we would need to do like this. And then right here, we would need to do that as well. So this is actually, I think this is actually the plain Conn. Technically. Because it is a TLS connection, but what's coming, this is where it's weird. It's a TLS connection, but what comes out of a TLS connection is the plain connection. The plain connection, what comes out of it is the encrypted data. So, you know, it's just one of those things where it's difficult to name right. Yeah. So if I abstract that away, then this comes out on its own. So I'm going to set this and as if we were doing a function. And then what I'm going to have here is terminate equals true. Then I can take all this I can't break out of that because it's not a function. Wait. Hold on. What am I doing? All right. So if, all right. So all right, so we're going to make this slightly more complicated in the short term. Actually, okay, we're going to swap this up. If not, error is do not terminate, then we're going to do all this stuff. And then none of that matters. Okay. Inverting that condition makes this block work now where I can only have to do this one time. The only difference being, all right, so that's all blah, 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 blah. So this is, hold on. LPN, blah, 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 blah. It's a proxy. Okay, now I think this is actually going to be the same as this. Let's see if we can just get these lined up and see what the differences are. So now if we do this over this, are these the same? All right, let's put this in here so I can more easily tell. I think these are now the same because proxy protocol doesn't matter whether it's terminated or not terminated. It's going to do the same thing. Okay, so the only difference here is whether or not that error is declared. Okay, great. So we're getting closer and closer to not so nasty. So if terminate, oops, then we add in this bad boy here. Okay. Else, we're done. And then we don't need any of this. Okay, that got rid of so much of the stuff that felt nasty. Nasty, nasty. Except that we still have this thing hanging around here that we potentially need. So how could we change this to be better? Conn ID, TCP port, blah, 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 blah. Okay. So this is all the same. Let's just double check that. I'm just going to throw this in here just for the sake of being able to see. Yep. Okay. So that's exactly the same. So how do we clean up this little piece? Because now we got this thing where we need to use this down here, blah, blah, blah. Okay. All right, here's my problem with it. So we got to do a little bit of duplicate logic checking, but I think that's a devil we can live with. So if we need to terminate, then we should attach the plain connection here. Oh, wait. Let's go back. No, I'm going to leave that there. But here, what we're going to use is that is the only place Conn is used. So we're just going to use this. Is that right? Okay. And I don't remember the difference between these three use cases, but I'm glad that they're close together now. Okay, so let's just take a look at this one more time. So what I don't want to have to do, I don't want to have a race condition where I'm modifying HC after I store it. That's the reason that I started down this bit of refactoring. So we want to get HC all set up. And I guess that doesn't matter. That this can all go together again. This is all the same. This needs to happen before that. And if the back end has a tunnel, this is where I'm a little confused. If the back end has a tunnel, we're going to inject the connection into the tunnel. But wait, what is this then? Okay, let's go back up to the top. BECon is net.con. get backend connection. Why do we not just feed it through a tunnel? Get backend connection, does a dialer, blah, 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 blah. Okay. I don't remember what the difference between these two is. Backend equals B. Oh, this is terrible. This also could probably be done a little bit elsewhere. Okay, I am confused as to what I intended with this. So get a backend connection kind of makes sense. So we're just going to connect to the backend. Great. That makes sense. So then this right here is a connection that we can just copy. Okay, understood. No problem. But this backend here and this tunnel, this is where I'm a little confused. Because the tunnel new listener. Okay. Okay. All right. Maybe I should call that an HTTP tunnel. All right. So the tunnel is if the connection is an HTTP connection versus the other backend is a TCP connection. That's what the difference between the two is. And the reason for that is because we've got proxy protocol, we've got HTTP, and we got TCP. So it's the method by which we're going to transmit the information about the connection to the service that's receiving the connection. That's why these are all a little bit weird. And that's why I had originally called it ProxyCon. Okay. Okay, so I need to adjust this a little bit. All right, and this is the better term than backend would probably be selected backend. And that's kind of implied. All right. Now I understand. Is raw TCP which I think there's a better way to go about this. I think that way is to establish the BEcon later. So we've got BEcon here, and then we set it up here inside of this whole thing. But the reason for that is we're round robining here to try to determine, why are we round robining here rather than later? What was the benefit of round robining here? Let's go back up. So yeah, I'm not clear where the benefit is on this. I think that this is accidental complexity, where this just got put here because it's where it got put, because we're trying to determine, yes, I do understand why this got put here, because we need to figure out if we can get the connection, because we don't, if the backend that we select is a bad backend, then we want to select a different backend, and different backends could have different manner of connection. So but I'm not clear that this is helpful in this scenario. Okay, I think if we back this up. So if the tunnel is nil, it's not HTTP, then we're going to select that backend. So we're not doing the same manner of testing here. So that this is inconsistent. Okay. So I think what we need here, instead of trying to we need to be more optimistic and just handle the failure. Because right here, what I'm trying to do is say, oh, well, let me go get that backend. And if there's an error when connecting to the backend, then I'm going to choose a different backend. And so we're just going to round robin through the backends to find a backend that doesn't have an error. And this is wrong too, because we could just get in an infinite loop where we try to connect over and over and over and over and over and over and over again. There's no way for us to get out of here. Could not connect to backend. Mark is inactive and try next. Okay. So, but realistically, I don't think we do want to do that, because that just introduces too much state. So yes, we do want to mark it as inactive. I have to think on this one. So yeah, this right here actually belongs elsewhere, because we don't need to reuse that connection. We just need to know if that connection failed catastrophically. And this complexity doesn't help us. So I'm going to do a little note here. So note, this complexity currently doesn't help us, but in the future we do need a way to mark a backend as active or inactive. Okay. All right, now I understand. All right, the tunnel is for HTTP-ish connections. The Yeah, this doesn't really seem to be helpful. I think that this is just wrong. But we'll leave it for now. Because it's working. It just doesn't do what we'd like. Realistically. Okay. Backend terminate TLS. Return error do not terminate. I bet we could even get, well, I don't think that we can get rid of this complexity. I think this is necessary. Well, this branching, this is necessary. Okay, so we did have let me just double check on something here. So we do actually need, see where were we, where do we have the length? Current backend. Because current backend is set. Where's, okay, this does not make sense. Oh no, here it is. Length of backends minus 1 is n. All right, so when instead of doing a mod, whenever we've reached n, we're going to reset to 0. And then start back at 1. So if we didn't set it to 0, then we're going to add 1. That's what this is saying. Okay. Oh, that took me a minute. All right, yeah, this definitely needs to have some refactoring magic done. But this is a lot cleaner. At least I can understand this a little bit now. Kind of, sort of, in a way. Okay, I am a little confused by this, though. Because this says doesn't block. But then, okay, let me go look at my prior code for this. I'm a little confused by this one. I need this to block. I need some mechanism to know when that TLS connection is done. Otherwise, we're just returning this here. Okay. Well, all right. Unused. List connections is unused. Okay, got it. That's true. All right, so we're gonna make that list connections used. So let's go into here. Oops, daisies. Okay, for right now, because of the way I have this set up, I think I do want to actually move this back. So we will have this. List connections. And then let's see, what did I do in there? List, whoops, no, and the API. All right, so let's take a look at this because I think I just pasted this in and I wasn't explaining it. All right, so we've got our connections, which is a map. It's got a v of any. We know because that we guarantee it, we know that this is going to be a TLS hello Conn. This type of assertion should get optimized away. So even though this is using an any, because of the modern Go compiler, that it should be much nicer in terms of performance. We shouldn't get that dereference penalty, but from the interface indirection. Okay, we've got our pecan, because I don't remember why I call it pecan, but we're going to have the address of the actual connection underneath, the real remote address, the server name, the selected ALPN. I mean, I guess technically it's no longer ALPN now, it is protocol, but I'm going to keep calling it ALPN here. How many bytes have been read, how many bytes have been written, and since. And then I actually would like to say, oh yeah, there we go. So if TLS Conn is not nil, then we're going to see the negotiated protocol, which should be the same as this, but whatever. Yeah, that should not have changed, but we're going to get it from the TLS state anyway. And then this would be then plain read and plain written. Pecan.plainread would be hc.tlsconn.bytes red.load. We'll do the same thing here where we assume, we make the bold assumption that a single connection is not loading more than 4.5 petabytes of data in a go. All right, let's see if this compiles. I will not be surprised at all if it does not. Will you? All right, so let's go back here. And then we should be able to go do one better. Oh, what's... Oh, look at that. We got a hello there too. Let's do API connections, and we should see one or two. Now that's not what I expected. Because I expected to see, for example, this connection. Okay. So what am I learning? Also, whoops. I had a call that I forgot about. What? Oh, whoops. Hold on. Oh, I said 3. Some people, calendars. I don't get it. All right, I gotta get off here. I do want to fix this one thing if I can, but then I gotta go, and then I'll get back on later. All right, so I think what's going on here is that there is one place where we are creating connection that we're not storing it. Yes, and I'm pretty sure I know where that is. That is the admin connection itself. So, but maybe we could create a non-admin connection for funsies. So could I go here and hit up, what was it, TLS router admin? Well, hold on. This one was cert magic. Okay. TLS router admin. That don't make no sense to me. All right, listen and proxy. I did actually restart this, didn't I? Just a moment ago. I mean, this is, let's see, how long does this say it's been up? 2 minutes? That sounds about right for me restarting it. Store. Oh, okay. So we're going to have to remove one of these defers for the time being. So we're going to have to get rid of this for testing, because we have this scenario where this exits. But then we also have another scenario where, let's see. So ideally, all of this happens in the same place, but there is one scenario. I think I'd rather add another if branch here. Okay, mismatch. This right here. There's this one. No, is it this one or is it contains backend? Okay, backend. LC admin tunnel. Got it. All right, so we do capture that one. But that one has a tunnel, and the ones that have a tunnel are the ones that are being terminated. So, and this is one of the ones that's being terminated, right? Yes. Okay, that's why we're having that problem. Okay. All right, so for now, just not doing that defer cleanup will be good. I need to find a way to have that connection that we inject to be able to wait for it to finish. So anyway, if I do this now, boop, and I do this, boop, and I do this, boop, yay! All right, and then we pre-print it, and that's what I expected. We have two separate connections, one for this domain, one for this domain, and they have so many bytes read and written, and then I can just boop, 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 boop. Interesting. So the read and written is kind of high on this side. And the written's very high on that side. So this every time I'm making a request, it's writing. So that number, it goes up, but it's only reading a few hundred bytes each time. I'm guessing is this compressed as well? I mean, this seems like this is more bytes than that. So I'm a little confused. How many bytes is this? Let's just check and see here. So if I go look at, just pop this open in the DevTools console dot length 385. Yes, I would be expecting these to go up by 385 each time, and that's not what's happening. It's going up by a third of that each time. I don't know what to make of that, other than that if this is doing, I may be getting the advantage of HTTP2 on this. That may be what's happening. Let's take a look and see. Because that would totally make sense in terms of with compression. It just doesn't make sense in terms of a raw connection. So let's see. Yeah, okay. Sweet. All right, so confirmed HTTP2 is working. Excellent. All right. So I'm going to go and I'll come back later. I will probably, I'll go ahead and commit this because progress was made. So tlsrouter.go, api.go, and then did we really not make any changes to, I guess we didn't make any changes to the other one. So, all right, cool. Whip list connections. All right, and I'm out.